Hi, everyone. Welcome to the Stack Overflow podcast, another episode of Leaders of Code, where we chat with tech leaders about all things security, leadership, technology, and innovation. My name is Ellen Brandenberger. I'm the Senior Director of Product for our Knowledge Solutions here at Stack Overflow, and I'm here talking to Dan from Abnormal Security. Dan?
My name is Dan Shiebler. I'm the head of machine learning at Abnormal Security. So we're a cybersecurity company. We protect over 20% of the Fortune 500 from a mixture of different kinds of cyber attacks, including email attacks and account takeovers. Our detection engine is AI-based. It utilizes a combination of more traditional statistical machine learning systems as well as newer large language model types of approaches in order to identify attacks. I've been in the security industry really only during my time at Abnormal over the last 3.5 years, but I've been in the AI fields for about 10 years. I did my PhD in the applications of category theory to machine learning, and including embedding algorithms, manifold learning, optimization. I spent about 5 years at Twitter working on vector databases and large language models, recommender systems, and ad tech. And I built some sensor data analytics systems before Twitter at a company called TrueMotion in the car insurance space. So we were acquired by a larger company. And so really been a great experience seeing a lot of the different components of how machine learning systems are able to be applied in the security industry and really bring good to the world in doing so.
So today I want to talk a little bit about sort of AI implementation in organizations, how that relates to cyber and sort of the emergence of AI within the space. And, there's certainly a lot going on in the industry right now. And so maybe we start with that, which is, could you talk to me and the podcast team a little bit about the challenges that you're seeing in implementation with AI in organizations, whether that's in software development or cybersecurity? How are things going? What are organizations struggling with? And where does your team succeed? And what are you doing well?
Yeah, absolutely. So I would say that this really splits into two very different categories of implementation, which have really different elements in terms of what are the challenges, what are the objectives, the ways in which organizations can be most successful. One is building AI into products. And this also decomposes into things that are utilizing more new age large language model systems, which tend to be a little bit more amenable to teams that haven't spent as much time utilizing these kind of systems in the past, versus building larger scale machine learning systems that require lots of internally owned data that you're able to optimize and tune for your particular application. And so that's all within the bucket of incorporating AI into your products. But then there's incorporating AI into your teams and your team's operations, which I think there's a great deal of that as well that we see, both in terms of improvements in software development, improvements in go-to-market structures, improvements in knowledge discovery. And in the first category, in terms of implementing AI in products, there's a number of different types of challenges that really are unique to when you're reasoning about systems that are inherently stochastic. But the AI systems, they generate different outputs based on different inputs, sometimes in very unpredictable ways. It's not always easy to understand how different kinds of changes actually will produce outputs. And a lot of things that you need to do need to be inherently empirical. And when you're working in an inherently empirical space, a lot of problems become data science problems. How do you analyze and evaluate the performance of your system? How do you benchmark the performance? How do you make improvements to it? How do you track those improvements? How do you reason about how different kinds of changes in your data shift because you want to onboard a new kind of customer as different types of data that they're going to have in their systems, or if you want to make trade-offs in terms of what kinds of system shortcuts you can apply to save costs or reduce latency, et cetera, how those different things will impact the actual performance of your product, what the customer experience will be. A lot of that is very, very difficult questions to answer when you have AI. And it requires a lot of data science, empirical approaches to how to optimize these systems. And that's common whether we're utilizing newer large language model out of the box types of approaches, or if you're fine-tuning or building your own machine learning models on a particular task that you have a lot of data on. In both those cases, in products. In workflows, a lot of it is around upskilling people and enabling teams to understand the limitations of the tools that they're utilizing, as well as how to optimally meet their tools in the middle. If you have a team of software developers experimenting with AI coding tools, two teams of software developers who are all exactly the same level of people with the same degree of experience and ability may have very different experiences in terms of how effective these tools are, just based on whether the code bases they're working with happen to be well suited for these tools or not, or whether the kinds of tasks that they're going to be doing tend to be well suited to how things work out of the box. And so there's a two component process of both understanding where limitations are and educating teams in terms of how to work around those, as well as modifying your workflows, modifying your code bases, modifying your documentation stack, modifying the integration points between your systems and the tools that you utilize in order to get the most out of them.
One of the observations that I've had in the industry right now, particularly from a more layman perspective of, product, is, it's interesting to watch systems that are non-deterministic, like AI, being implemented in a world that's sort of used to SaaS, where like everything is deterministic and linear and maybe works out of the box. But sort of understanding those variable use cases, benchmarking them, evaluating their performance, and then improving on them is a much more iterative process. Making that shift from whether it's in how you build products that are driven by AI or even how you implement those tools within organizations, both sides have struggled with that, I think, in the industry as well. So there's certainly those challenges across the board. With that, I think there's a lot here, and in the industry more broadly, you have deep experience in machine learning, as you articulated earlier. How do you differentiate between what's sort of the next hype cycle in tech, whether it be versus like a really good, strong reality that can unlock doors for innovation and the next wave of products or efficiencies for either teams or organizations? How do you think about the different pieces of that?
Yeah, I mean, I think that there's two things to think about. One is whether a system is really, in its strengths, effectively tackling what the bottlenecks are on certain problems. And then the other is whether the limitations that exist right now are limitations that we naturally expect to be things that fall away with time, or if we expect them to be things that are somewhat immutable in their structure. And for the first one of the biggest limitations in machine learning over throughout my entire career is availability of data to train models. That if you want to build a machine learning model that accomplishes a task, you need to have a lot of data of examples of that task to be able to train your machine learning model. And your model is very unlikely to perform well on tasks that are substantially different than what it's been trained on, both because there's a feature input space that is fixed and the model doesn't really work with anything outside of that space, and because there's a single task that it's performing. And so if you wanted a model to perform a different task, you need to train a new model to do that. Large language models are a complete paradigm shift in terms of their what's at one point was called their zero-shot generalization capabilities, and now people just sort of refer to as just the capabilities of large language models, in that they can perform tasks that they were not trained on. If you can think up some task, you can try a large language model out on it, and a lot of the time it will do pretty well if you present the information to it in the right way, and if you set the appropriate expectations of what its output will be. And so that's a complete paradigm shift, because it takes something that's just a fundamental bottleneck and decomposes it, breaks it down entirely, and essentially removes it. It unlocks an entirely new set of kinds of products you can build. It completely changes the equation of whether or not a product is something you can build by yourself from scratch in your room, or if it's something that requires you to have a tremendous number of customers and data that is blocking you from being able to build that. And when we think about the other component here, which is what are the limitations in what we're building, and are those limitations things that we naturally expect to fall away? There's a blog post that was written in 2019, I think, called The Bitter Lesson, that's reasoning. It presents a description of how a lot of tricks that people apply to artificial intelligence systems, machine learning systems, that don't naturally cause the system to perform better with increased compute and increased scale will often be outperformed by systems that can perform better with increased compute, increased scale. And so when we think about what are the innovations that are happening in the industry, what are the ways that things are improving, any kind of innovation that is something that opens up the capacity to see substantial improvements as we increase scale, or any kind of limitation that we see, or if we expect that the increased scale can help us break through that limitation, then that's not a limitation to think too deeply about, because over the course of a couple of years, it will likely fall away. Whereas things that are more foundational and things that are less likely in their core to be something that can be simply removed by increasing scale, by increasing adoption, by increasing things that we expect to naturally have tailwinds behind it, those are things to pay a little bit more attention to as foundational limitations.
Do you think within the AI space there are, you alluded to some, but are there foundational limitations in the AI space that you think are inherent risks? Do you expect certain ones just fall away with scale?
Ultimately, any kind of probabilistic model is sometimes going to be wrong. It's sometimes going to generate what's sometimes known as hallucinations, and be able to have outputs that are logically inconsistent in their structure. This isn't something that naturally falls away with scale. It's something that can improve with scale a little bit, but ultimately these kinds of inconsistencies that are drawn from the absence of a well-structured world model are always going to be present at the edges, present at the core of a lot of the systems that we're working with and systems that we're reasoning about. And the way that systems today are effective at operating without those even when those kinds of problems are in place, is by building checks and guardrails and non-AI components to systems that are AI centric, so that you have a mixture of more traditional approaches and of large language model approaches in order to deliver experiences that have higher degrees of predictability for end users.
What are some good examples of those checks? Like you talked about whether they're systemic or people. Could you give me a more specific example, maybe from your own work? I'd love to hear if there's examples coming out of Abnormal that are relevant here.
Yeah, absolutely. So I can give two examples. One, just a general example that's very relevant for operations, and then the other for just products that we specifically build at Abnormal. So from the operational example, very simple to just look at code and look at AI models that generate code. Code has a natural structure to it, and when it deviates from that structure, it's often very easy to spot. Sometimes it will cause syntax issues, and sometimes it will cause runtime issues. And you can spot these by simply running your code through a linter or trying to run your code itself. And a lot of AI systems that are really effective at writing code and doing multi-stage programming tasks have within them calls to systems that perform linting or perform runtime checks or even run unit tests or integration tests as part of their execution. And so by sticking together these more structural automations with large language model generation, you could have a system that's much more reliable in terms of its end structure. And at Abnormal, we have similar principles for attack detection. We have large language models that perform attack detection, but these sit alongside more rule-based systems that are looking at the structural components of messages that we're processing, things like indicators of compromise and behavioral traits that are extracted. So these work in concert, where the decisions of large language models are then checked to fit into larger rule engine systems that check them against other components, and then those outputs feed back into other large language models, building a system that has checks on both sides and concordance all throughout.
Nice. How successful have those been? And like, what challenges did you and the team kind of have with implementing something like that?
So there's a lot of challenges, as you might imagine. In general, it's very effective. We've seen that the combination of more traditional approaches along with agentic systems is really good at enabling us to both sweep up attacks that come from any degree of maliciousness present in it, while also being able to filter out the types of obvious false positives that somebody who's an analyst looking at an individual message might be able to say, oh, I can see why this is a false positive, but I can see why something flagged it. A large language models are very good at understanding that and being able to integrate that integrate information together with why something was flagged and why something was recognized, the contextual information something lives into, and then make these decisions. So you have these sort of two different types of things that work very well together. One is whether you have a more rule-based approach for picking up things that might be malicious, and then a agentic approach for investigating and making decisions on those. And then the other is a more machine learning model approach for picking up things that have elements of suspiciousness and elements of anomalies to it, and then more rule-based approaches that are checking for known patterns in an organization's environment. So these two fit together very, very well. I would say a lot of the core challenge comes down to evaluation of interlocking components. And anytime you have multiple pieces to a system that need to fit into each other, you need to evaluate them both individually and then as a system as a whole. And that can be very complicated in order to think about how is somebody working on one component of the system able to reason about the performance of the way that their work contributes to the whole, especially if somebody else is working on the other component at the same time. A lot of coordination. People problems are always the hardest kind of problems.
Exactly. I mean, if you think about even the example you just gave of like a false positive with an analyst, there's also a human in there, right? Like asking questions of like, okay, maybe I'm giving signal that this is a false positive, but I still have to like independently and decide if that answer is right and evaluate that as I do my own analysis. But then, more broadly, to your other point, contributing to machine learning systems and AI systems going forward might be the new version of contributing to a larger code base. And so how do we think about building teams that build AI in coordinated ways? So with that, I want to shift gears a little bit. You mentioned AI agents, which is a very hot topic right now. There's certainly folks in the industry who know a lot about agents, but I think it's one of those topics that there's not a shared definition of. So maybe before we talk a little bit about how agents impact abnormal and sort of the work that you're doing, how would you define an AI agent? And I'm happy to share kind of how I've been thinking about it as well.
In order to build a definition that's actually useful, we need to acknowledge that, for over a decade now, every kind of large software system of any size has had components in it that are mediated by machine learning systems. There's any kind of decision that has any degree of relationship to revenue or user experience has at some point in its processing pipeline a machine learning system that's making a call, classifying something and predicting something. And so if we just wave our hand and say it's an agent's anything that involves the machine learning system or an AI system anywhere in it, then we can say everything is an agent. That's not very useful. I would say that if we're going to bring in the definition of an agent, we need to be a little more specific than that. And I would say that it's a system where there's decisions being made in how execution is going to be routed that's based on the decisions of a large language model that is not just a single binary classification decision or multimodal classification decision that's pre-baked in advance, but instead something that actually has a true degree of control flow mediated by a large language model at its core. And there's a lot of different forms of that between these more unstructured kinds of approaches where there's a high level objective and that's fed into a system that has lots of tools, or these more structured approaches where there's agents that are given individual subtasks that are sent out in swarms in order to put together overall components. But ultimately, I think once you reach a certain point of control flow mediated by large language models, then you can sort of graduate your system from software that has a large language model in it somewhere to agentic system.
Yeah, I really like that definition. I'd previously been sort of talking to my own team about this through the lens of typically I think of an agent as three things. One being some computational logic, to your point, some system that's non-deterministic that might make decisions based on the output of a large language model or some form of machine learning, and then some data set that can help inform those systems. But to your point earlier, it's probably a little bit too broad. So I like the narrowing in based on kind of the outputs of the large language model and having higher level of agency baked into the word. So that in mind, could you talk to me a little bit about, whether it be at Abnormal or broader trends you've seen in the industry, what are some key challenges that the space is facing in terms of ensuring AI agents can accurately assess, access, and use data to reason effectively?
So I think that there's both security challenges and performance challenges that are top of mind for a lot of people. I think from a performance perspective, a lot of this is just there's traditional challenges that are associated with machine learning systems that have always been present. They're very difficult to reason about. AI and large language models make it possible for larger groups of software engineers in order to build AI into many more products much more easily. When you're able to just take a product and just stick it out there, you never need to actually train a model. It's easy to forget about the fact that it's an inherently stochastic system, and then you need to reason through all of these performance elements. We're taking this problem that used to only exist within systems where you had to do a whole bunch of pre-work in order to launch it, now sticking it into everything. Those performance problems and performance management, performance optimization, I think it's very much just the same old machine learning problems, just sort of brought in and now scattered all over everybody's code base that's touching large language models. The security issues I actually think are quite unique, though, because I think that there's a number of different elements here, both within the degree of access that people want from large language models. A lot of the time, in order to give your large language model access to the data that you wanted to have access to and access to the systems that will make it most effective as a tool that could do a lot of work for you, you need to reason about how it's going to be able to touch all of those different systems, touch all of those different pieces of data in a safe way. Your role-based access controls that you've been able to implement for your workforce, you now need to propagate out to all of the agents that the different people in your workforce are utilizing. You're reasoning about the way in which data that is fed into a large language model might be essentially accessible by anybody who touches a model that has that data in its context. It's very easy to prompt large language models into spilling anything out. So any data that's touched by an LLM is basically totally public with very little effort to anybody who is interfacing with that LLM. That's not necessarily how many people have been developing these systems with that in mind, with that degree of just openness in terms of data access, but it really is necessary if we want to be able to maintain the kinds of security and privacy that we need from enterprise systems.
And I know for many enterprises, like that security piece is sort of a table stakes feature in terms of adopting AI systems. And so there's quite a bit of anxiety out there right now. Can you talk to me a little bit about any ethical considerations that might come into play, whether that be, how said data is used or how things interact with users? And you alluded to this earlier, but like what safeguards make the most sense to help enterprises as they start thinking about AI agent adoption?
Yeah, I mean, so I'll say one thing, which I think is one of the largest ethical concerns that we think about: malicious actors utilizing large language models and utilizing AI systems in order to improve the quality of attacks that they're sending out. This is a very serious problem. We've seen a substantial increase in threat actors utilizing artificial intelligence systems in order to craft more realistic phishing emails, or to automate OSINT workflows in order to be able to simply up-level the degree of effectiveness of their malicious campaigns. The reality is that AI tools are a tool that enable people who are less skilled technically to be able to operate as well as people who are more skilled technically. And this has both positive effects in terms of the vast majority of people who utilize these tools, and it has negative effects in terms of enabling bad actors in order to be able to send out more malicious things to all of the victims that they're targeting. That's one very, very large element, certainly. There's also substantial components in terms of the privacy considerations, of course, and how a bad actor is able to potentially get large language models to be weak points in companies' security infrastructure by introducing large language model mediated systems. If you're not careful to be able to propagate the same kinds of access controls with the perspective that anything a large language model touches is completely open to anybody who touches it on the other side. If you don't have that baked into the way that you've designed your system, then you open up to user data being leaked by people who are interfacing on the other side, and that itself has a number of concerns as well.
So one last question on agents before we shift gears a little bit. So how do you see agents evolving? Do you see them becoming more popular? Do you see their adoption rising? What challenges and what does the future look like?
I certainly think automation is the theme today. I think that there's a tremendous number of workflows that were able to be automated by computers, and by the introduction of really nice tools that people have been able to utilize in order to take systems that would require a lot of manual steps and be able to automate them using code and computers and APIs and workflow orchestration systems. And I think that there's a lot of steps in those processes that before large language models, before agentic systems, were almost impossible to automate in a reliable way, to the degree of ambiguity that what would need to be performed at different stages. And now that's no longer the case. At one point, it was very difficult to automate anything. Then we were able to automate quite a lot. And there's a sort of concentric sphere of things that we couldn't automate yet. And now we can automate a lot more things. And so I think that's a huge thing that we're going to see across every industry as people figure out what are the things that a year or two ago were almost impossible to automate, and now is completely possible to automate to an acceptable level of performance. I don't think anyone knows exactly what these lines are, what are the things that are and aren't possible to automate, but I'm sure everybody who works in any field probably think of a couple of candidates that they see. Certainly at Abnormal, there's quite a lot of things that's workflows that we've seen in the past have required human in the loops, and now we've been able to automate them and really be able to increase productivity across our organization and the performance of our product through those additional automations that we're introducing. I think in particular, the ability of AI systems to write code really is one of the most compounding effects, because of the fact that the code itself can do things like produce automation and improve the performance in various systems and be able to fill gaps.
Yeah, or find bugs or commit code or whatever it may be. Yeah, exactly. I often, as my team builds products, I often ask them, what are some things that are possible with this technology that weren't possible 2 years ago, 6 months ago? And I think, being in the AI space can be challenging, but it can also be very exciting to sort of ask ourselves that question and have a really good answer. And we're able to automate away some of those things that, whether it's code or otherwise, that ultimately aren't to our benefit short term. With that, let's change gears a little bit. So, are your teams using AI right now? I know you build AI systems, so I suspect the answer to that is probably yes. But what are some of the benefits that you and your teams have seen there, and ultimately, what really excites you about the industry overall?
Yeah, we're using AI extensively. We actually track utilization of lines of AI generated code very religiously across our organization. We have a number of different internal hackathons that are based around trying to build as much as we can without writing a single line of code ourselves, just prompting systems, and even a lot of work that we've done. One of the things I think that's most effective within our organization has been the generation of artifacts that enable AI systems to be more effective. So these are things like rules files for AI systems that give them context on our organization, on some of the sharp edges in our code base, on the structure of our team, on each of the different ways that our information is organized in order to make them more effective. We have internal systems that give us access to all of the kinds of organizational context that is present, so that anybody who's looking with a question for the context that might be hidden inside of a Slack channel somewhere, or hidden inside of a conversation somewhere, or in code, can be surfaced very easily. And the net effect of a lot of this is a compounding productivity that comes from making these kinds of investments in order to make AI systems work for our organization. A lot of these things don't necessarily work out of the box. It takes a little bit of investment. It takes a little bit of key decisions in order to shape our organization, shape our artifacts, shape the tools that we use in order to match it optimally for our environment. But the compounding effects are very real.
So, last but not least, what's exciting for you in the AI industry right now?
I think the pace of innovation is incredibly exciting. I think the fact that people are being able to do so many different things with these tools and think of creative new ways to utilize them, I think gets me out of bed in the morning is our mission. I love stopping attacks. I really feel like it's not many people who get to feel like they are on the front lines of a war against the existential threat. Cybercrime is an existential threat, and fighting it with, all the tools at our disposal, and AI is a very powerful tool, is a very exciting thing. And I love being able to do that. And I think that there's a lot of advancement that comes in every way. Tools that both enable people to become more productive and also enable the products that you build to be more effective at the same time is something really worth spending a lot of time thinking about.
Yeah, that's similar for me as well. Like the idea that we can both build better products for developers and technology companies, and then also build better ways for our teams to work. It really makes me excited to be at Stack Overflow as well. Although we're not in the cyberspace, we certainly power developers and cyber teams across the world. So, good to share that goal, albeit indirectly. Dan, anything else you want to add about topics of discussion that we've had today about the AI space or about your work at Abnormal before we wrap up?
I would just reiterate that AI systems are a bit of a double-edged sword in terms of the complexities that they introduce, the difficulties of being appropriately responsible in how data flows that are required in order to get AI systems to work can be done in a safe and secure and private fashion. And they require a lot of upfront investment in terms of really mapping how they'll fit into an overall organization structure in order to build that buy-in. This is a people problem more than anything else. It's a people problem and an education problem and an investment problem. But the results are truly transformative, and the results they're self-compounding as well. I would encourage organizations and people who want to utilize these tools to take the time to think through all of these kinds of challenges and all these kinds of hurdles to jump over, but to not lose sight of the very, very real benefits that lie on the other side.
Yeah, I love that metaphor. I think as organizations think about adopting a lot of these technologies, unlike, SaaS or previous technology waves, the upfront adoption cost is probably a lot higher, but the benefits could also far outweigh that as well. So I'm starting to see that abnormal, as you pointed out, but, as we work with partners at Stack Overflow, we certainly have seen that as well. So thanks so much, Dan. Appreciate everyone for listening. I'm Ellen Brandenberger, and you can find me on LinkedIn under my name. Or if you'd like to learn more about Stack Overflow, you can go to stackoverflow.com to see our millions of questions and answers, or stackoverflow.co, C-O, if you're interested in learning more about the company Stack Overflow. And we are hiring as well. So if you're interested in taking a job with us, take a look at our site. And Dan, I would love to hear where we can find you.
You can learn more about abnormal security at abnormalsecurity.com. You can find me on LinkedIn. My name is Dan Shiebler. Please feel free to reach out.
Thanks so much, Dan. We appreciate having you on.
Thank you.